In today's video, I'm going to show you a great way to recycle LED backlights from broken laptop computers. In a previous video, I have shown my viewers how they can make good use of broken laptops by removing the CCFL backlight and inverter board from older laptops in order to use them for light tracing tables or light panels. To view that video, you can click on the video shown here to open a new window, which you can pause until you have finished watching this video. There is also another great video on YouTube, which was uploaded by Matt to his channel called DIY Perks, and he did an excellent job showing how you can make an artificial light source which resembles a window using LED backlights. Be sure to check out his video. I will place a link in the video description area. The first thing that we're going to do is make sure the laptop that you're going to be using uses an LED backlight and not a CCFL, which is a cold cathode fluorescent lamp. Now it's very easy to do that. You can go onto Google and enter into the search box the type of computer. In this case, this is a Dell Vostro 1500. You can also take a look at the bottom of the computer. There's a white tag right over here. That's the product ID, the product code, and you can also go to the website for Dell, enter that tag number, and it will give you all the specifics on this laptop. The information that's going to be of importance is pertaining to the display. You want to make sure it says LED, and it does not say CCFL. If it says CCFL, you will not be able to do what I'm about to show you. So make sure it says LED backlight. Now let me show you what you're going to be making. For this project, we will not be using the entire LED backlight panel. We're going to be removing the panel from the computer in order to disassemble that panel to remove the LED light strip that you see here. Now the light strip contains 32 LED chips. You can see them all lined up here. Because my light strip is going to be used in an area where space is an issue when it comes to length, what I did is I trimmed off the end, the last 8 LED chips, in order to make the strip shorter. The project enclosure could be any piece of plastic you have laying around. I had this laying around in the garage, so I hollowed it out in order to fit my circuit board. I'm going to be showing you the full schematic for the circuit that's inside this project box, as well as how to connect it to the LED strip light. The good thing about this strip light, you can adjust the brightness with this potentiometer. You have a line switch. This switch would be positioned in an area where it's easy to access in order to be able to turn the light strip on and off. The one you see here is designed for a 120 volt power supply. You can also use this with a 230 volt power supply if changes are made, which I will show you in the video. The LED strip is very, very thin. It's flexible. So what I did is I added this brass strip. You could pick this up at a hobby shop. It's usually available in a box with all different types of metal strips. Be sure to pick out a metal strip, aluminum or brass, whatever you can get your hands on. That's slightly wider than the LED strip that you see here, and just a little longer. It has to be longer because you're going to have to glue, in my case I use crazy glue, this metal strip onto the back of the box in order to make the whole thing rigid. When I use double stick tape to secure this underneath a counter, everything stays nice, nothing's flopping around, so you definitely want to have a metal strip. Any power cord will work fine. Considering the low level of current that you're drawing for the circuit, which is only around 3.5 watts to drive this entire strip at full brightness, the amount of light that you get out of it is incredible. Let me give you a quick demo. I'm going to turn on the light switch and show you how this lights up. Alright, now this is pretty bright. If you turn this on in a room that's dark, you would be amazed at the amount of light that you get off this LED strip. And I could adjust the brightness right here with this potentiometer. Could turn it way, way down. All right. And the reason why we're able to use a potentiometer on the output to the LED strip is only because around 60 milliamps is going to be flowing into this strip. So the current level is very, very low. It's not enough to burn up the potentiometer as long as you're using a 0.5 watt to a 1 watt 5K potentiometer like I'm using right here. Turn it back up. And look how bright that is. I can turn it back down. It's actually pretty blinding for me to look at. Set it there, all the way up. Now I'm going to show you how you can put one together. Okay, you're looking at the LED backlight panel, the rear side of it. At the bottom edge, you can see the circuit board. We're going to be sliding the flat cable out of the circuit board to disconnect it. The circuit board you're going to be throwing in the trash. The flat cable then goes from the circuit board towards the left side of your screen. You're going to have to very carefully remove that flat cable from the entire backlight panel. It runs up the whole left side of the screen. You're going to pull it all the way up to that top edge where you can see the aluminum plate that runs along the top. The LED backlight strip is located inside the very top edge of that aluminum channel. In order to remove it, on each corner of that metal strip, on the left side and the right side, is a very small Phillips screw. You're going to remove the Phillips screw, and then you could slide off the metal strip. There may be tape attached, which you have to cut with a razor. Once you cut that tape, that strip should slide off easily. Carefully pull out the flat ribbon attached to the backlight strip and remove it entirely from the panel. Once that metal strip is removed, it's shaped like a J channel. Inside the bottom of that J-shaped aluminum, you're going to see the LED strip. You're going to have to carefully spread open that J and carefully lift up on the LED strip and slowly pull up and away. There is double stick tape on the back, so be very careful as you're lifting it. Do it slowly and you will have no problems removing it intact. What I want to do now is show you how this strip is set up. Alright, let's take a closer look here. On this side of the first LED chip, located right next to where the cable goes in, that is a positive connection. The strip is set up in 4 sets of 8 LEDs. So you have the positive right at the beginning, negative, positive, right? Keeps connecting in series. So you got to connect 8 of them together. So 1, 2, 3, 4, 5, 6, 7, 8. On this side of the 8th is the negative. So you would have your positive here, and your negative would be on the 8th, which is there. And then you would have to supply approximately 25 volts. I like to drive it a little higher, around 3.1 to 3.2 volts per LED. You could drive it at 24 volts, which is 3 volts each. Everything will work fine at 24. I just prefer to have it a little brighter, which is why I use 25 volts. So this is one segment. Over here now, the 9th LED, you have positive again. Keep in mind, this positive here is the same connection as the positive at the beginning. So we go back to, let me see if this is the 8th. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have positive again, then you have another set of 8, and then you got negative. Then you got the same thing again here, positive, and then you got 1, 2, 3, 4, 5, 6, 7, 8. And this right here is the negative again. You're going to get all the negatives, tie them together. You're going to get all the positives, 3 of them in my case. If you're using the full strip, you're going to have 4 positives, 4 negatives. You're going to connect them in parallel, and you're going to be supplying approximately 25 volts to all of those LEDs in parallel. You have 4 sets of 8 at 25 volts. Let me show you what the ribbon looks like at the other end, how you're going to be connecting it together. Okay, as you see in this image here, this is the end that you slid out of the circuit board. The circuit board is what supplied the power to drive the LED strip. Now pins 1 to 3 are soldered together. It just appears as 3 fingers spread off of the same trace. So just solder all 3 together. Then on the opposite side, pins 7 to 10, you're going to solder all 4 of those together. Each one of those represents one set of 8 LEDs. Number 10 connects to the first set of 8 LEDs closest to where the ribbon cable connects to the LED strip. And then the next one down would be number 9, and then the next one after that would be number 8, and then number 7 would be the very end of the LED strip where the cable is not connected. So solder all of those points together like you see in this image right here. Here you can see where pins 1, 2, and 3 are soldered together as one. That's where the plus 24 or 25 volts is going to be soldered to. And on the left you can see where pins 8, 9, and 10 are soldered together for the negatives for those 3 sets of 8. That's because I'm only using 3 sets of 8 on the strip instead of 4. If you're going to be using 4, then you're going to want to make sure you solder pins 7, 8, 9, and 10. That will allow all the negatives to be tied together. Now I'm going to show you the circuit that I put together to drive the LED strip light. I'm going to be showing you a few different ways to power your strip. The top is 120 volts using a transformerless power supply, and below is for 240 volts showing a step-down transformer or a transformerless power supply. This is exactly what I used in my LED strip. Keep in mind I use this with 3 groups of 8 instead of 4. So I'm going to show you one change you're going to have to make to be able to use this for all 4 groups of 8, which is 32 LED chips. Here you have your 120 volt line. This right here is a 50 milliamp fuse. Try and keep this under 100 milliamps because the amount of current that flows into this circuit is very low. It's around 30 milliamps. So keep that well under 100. You're going to need a 250 volt non-polar 0.8 microfarad capacitor. Now type X is preferred, but if you only have poly capacitors, they'll also work well. Be sure to have this 470K quarter watt bleed resistor in parallel with that capacitor. If you don't have 0.8 or any other value that you're looking for, remember you can connect capacitors in parallel, and then the capacitance will be the sum of the 2 capacitors. So if you have a 0.47 and you place another 0.47 in parallel, you'll have 0.94 microfarad. I'm only using 3 groups of 8, so 0.8 microfarad is sufficient. If you're going to be lighting up the entire strip with the extra group that I didn't use, make sure you use 1 to 1.1 microfarads. If you use 0.8, the voltage will drop too low and then you will not have good brightness. So for all 4 groups, you want to use 1 to 1.1 microfarads. Over here you have a bridge rectifier. You can make this out of 1N4007 diodes. Connect them up as shown, or you can use a bridge rectifier that comes in its own little package like I use for my project. On the neutral side, you're going to have a 220 ohm resistor at half watt, and that's to help limit the inrush current into the whole circuit. That connects to over here. This is the alternating inputs right here. And then you have your DC output, negative there, positive here. Positive comes down, and that goes into a 100 microfarad 35 volt electrolytic capacitor, and that's to smooth out all the ripples. And I also added a 30 volt 1 watt Zener diode. You really are not going to be using that diode for the simple fact that the circuit is connected to the output at all times when it's turned on or turned off. I used it just to ensure that in the event that there's a problem with the LED strip light, the voltage will never rise above 30 volts across the output. Once the LED strip is connected, and if you have it at full brightness with the potentiometer, what's going to happen, this will be probably around 24.5 to 25 volts across the output. So you're not even going to be anywhere near the 30. To adjust the brightness, On the output right here, you're going to be using a potentiometer. Let me draw that in. So from the output, instead of this going to the LED strip, you're going to go in, all right, to one side, and then you go like this, and then like that. And then this right here would be your positive connecting to the LED strip. Now keep in mind, this over here is a 1/2 to 1 watt 5K potentiometer, and by using that 5K you'll be able to regulate the brightness of the LED strip without any issues. Now you're not putting that much current through this resistor, so that's why we're able to use the potentiometer in this manner to limit the current. The maximum output current using 0.8 microfarads is approximately 60 milliamps at 24 volts. If you raise this to the 1.1, then you'd be putting out closer to 80 milliamps, and you should still be fine. I would just try and go to the 1 watt if you have it, to make sure that this doesn't heat up at all. Now when I use this, I don't have any heating coming from this potentiometer, using it with the 0.8 microfarads, so I don't think you would have any issues if you did use the 1.1 microfarad value. Right here, the negative and the positive connects to the spots on the LED strip where I showed you that I soldered. This circuit you see right here only draws around 3.5 watts off of the 120 volt line. And the light that you get out of this strip is truly incredible, considering you're only drawing 3.5 watts. Now if you're going to be using 240 volts, because the voltage is much higher, I would suggest, for safety reasons, that you use a 240 volt step down transformer to 24 volts, and I would keep it as close to 10 watts as you can. You can use up to a 25 watt if you would like. Over here you have your AC input, 240 volts. This is your lower voltage output of 24. When this is open circuit with nothing connected, that 24 volts will probably be around 32 volts. So we're going to take that alternating 32 volt no load output, and that's going to be connected into a bridge rectifier as well. The bridge rectifier, if you use one that's pre-packaged, it could be extremely low in current, a 100 or 200 milliamp rating. If you find one that's 1 amp and it's really inexpensive, you could just buy the 1 amp rectifier. The positive output comes across into this Zener regulator circuit, 75 ohm resistor, 1/2 watt to 1 watt. If you run the circuit and it works fine and you notice that this is not getting hot, then you leave it with the 1/2 watt. If you notice this is becoming too hot, you're going to want to increase the wattage to 1 watt so this runs cooler. The Zener is a 25 volt 3 watt Zener. Cathode connects to the resistor and to the positive output, which is 25 volts, going to the location on the flat ribbon where I showed you the soldered areas. And the anode goes to the negative and over to the negative area of the strip where I showed you where the solder is, pins 7 through 10. If you don't want to use a Zener regulator circuit, you can also use an LM7824 regulator. That'll keep the voltage around 24 volts, very steady. That will work just fine. Just be sure on the input to the voltage regulator, you have a 100 microfarad electrolytic capacitor between the input and the negative rail, and on the output, make sure you have a 10 microfarad electrolytic connected to the negative rail. Now the one above is the transformerless power supply. You could use a 63 milliamp pico fuse all the way up to a 100 milliamp fuse. Because we're using twice the voltage, you're going to want to make sure you're using minimum a 400 volt rated capacitor. Once again, type X is preferred. And type X capacitors looks like what you see right here. 0.5 to 0.6 microfarads. Now because we're using higher voltage, it requires half the capacitance to produce the same amount of current at the output. Use a 1 meg ohm resistor, 1/2 watt, in parallel with the capacitor, and then the other alternating input right here connects to a 220 ohm resistor, 1 watt, and that's also to limit the inrush current. This pretty much stays the same. You have your 35 volt 100 microfarad electrolytic. Then you have a 30 volt Zener. The only purpose of having this Zener is in the event that the LED strip is not connected or there's a fault. This will keep the voltage low, around 30 volts, instead of having it climb all the way up to 120. If you're only going to be using 3 sets of 8, stick with the 1 watt. If you're going to be using the entire strip, pick up a 3 watt Zener diode. Now, one more thing I wanted to add. If you would like to use this LED strip light inside your vehicle, which operates between 12.5 volts with the engine turned off and around 14.25 with the engine running with the alternator charging the battery, then you can always pick up one of these very inexpensive DC to DC step-up converters like you see in the image right here. You can connect the input to your vehicle's electrical system and then set the output at 25 volts, and then you can power this light strip with no problem at all. Now what I'm going to do is show you a couple of close-up images of my circuit inside that plastic project box. In this image here, you're looking at the back side of my circuit board. At the very bottom, you can see where the white AC line is coming in, and I scraped away all copper between those two terminals to ensure there's a wide enough space that there will not be any shorting out between the hot and the neutral wire. All the way to the left, the orange goes between the potentiometer and the cable heading to the LED strip. You can see it says number 1, that's the positive. Off to the right on that ribbon, you can see the 10, and that's where all the neutrals are connected to the output. This image here shows what it looks like inside my project box. You can see all the components, all clearly identified. One is hidden. There is a 1/4 watt 470K bleed resistor, which is laying flat between the two non-polar capacitors. In the very center, the long black strip sticking up is the full wave bridge rectifier. Be sure to use a 200 volt minimum when operating at 120 volts. When operating at 240 volts, make sure that is a 400 volt minimum. The last thing I would like to do is show you how simple it is to add a line switch to your AC power cord. Connecting a line switch like you see here to a 120 volt polarized power cord is very simple. You're going to look for the section of the cord that's going to be easily accessible so you can easily turn on and off the LED light. For my LED light, I decided this area of the power cord is where I would like to place the switch. If you look carefully on a polarized cord, you're going to see one side has ribs that run vertically. That is the neutral side of the wire, and the other side is smooth, and that is the hot AC line, in this case 120 volts. I'm going to be cutting a 1/4 inch section of the AC line, the hot side, leaving a space, and the switch will be installed right over that area. As the dial on the line switch is rotated, the circuit will open and close, turning the LED light on and off. So the first thing I'm going to do, I'm just going to cut a little bit of a space right in the middle here. Right? See, that's open. Let me cut that little piece out. Let's cut that little piece out. Now I'm going to remove the screw here from the line switch. There's a nut on that side. This is going to be positioned just like this. All right. If you look very carefully, at the back you can see a brass little point sticking up and one over here. That's going to dig into the hot side of the wire here and there, allowing the circuit to be open and closed. Let's connect it back. Push down. Tighten down securely. And you're complete. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to my videos on other websites and blogs. Also be sure to check out my video playlists as well. Thank you very much for watching.